So let's talk about hard water, seepage, and permafrost. And this will directly relate to some of the things we saw in our lab activity. This are the key concepts and vocabulary that I expect you to take away from this presentation. Now, you do not have to write down these questions in your notebook and answer them as we go through it. It's not a requirement, but I am telling you, you have to take some notes in order to get credit for doing something, getting it done stamp. If you want to copy these all down and answer them, this is what you're expected to learn, because this is what I'm going to teach you from this presentation. All right, first of all, we know that it rains, water seeps into the ground. There's a big collection of water under the ground, and that it can come back up out of the ground, either naturally as a spring or we dig a well, go down there and get it. We know that groundwater has different amounts of minerals in it because as the water goes through the ground, it picks up minerals from the rock it passes through. This is not quite as dramatic as what you did with the mineral water that I gave you in the lab, but you can see that the Perrier water, which we remember that was our number one in our water tasting example that you guys didn't like because it had a strong mineral taste and it's actually labeled as mineral water. Well, I boiled off a sample of it and you can see there's a residue left behind. That's minerals that are in water from the ground. We tested limestone versus granite. My question to you was, which one put more minerals into the water? Because we shook it and we basically made the water go through the rock. Well, if you notice the limestone, it's very, very cloudy. There's lots of stuff in there. So there was a lot of minerals that came out of that limestone. Yet the granite is particularly clear, not nearly as cloudy. So not nearly as many minerals came out of the granite as came out of the limestone. So when water is going through limestone and back to the surface, it naturally, you can see, it brings a lot of minerals up with it. When water comes up through the ground from granite, there really isn't much minerals to come up with it. So different types of ground give us different amounts of minerals in our water. That's what hard water is. Hard water is really water that has a lot of minerals from the ground in it. So water coming out of granite, definitely not hard. Water coming out of limestone definitely is. And the hardness is kind of a scale. It goes all the way from soft to very hard. So it's not an exact number, but it's kind of like a rating of how hard, how much minerals water has in it. Now, if your town or your house uses a well or a spring, that means you've got hard water in your house. So if this were limestone that your house is on top of and it rains a lot and the water comes back up, you're going to have hard water going into your house. And I want you to think of all the places that water goes in a house. First of all, let's look at the toilet. The toilet constantly has water going in it. And if you've ever watched the toilet fill up, you know, the kind of water kind of drains down like this to fill up the bowl to a certain level. Then the water turns off. Well, the water had minerals in it, which means anytime the water is running over something or in any location, it's going to leave a little bit of those minerals behind. You can see it here in the toilet. It kind of stains the toilet. You have to work very, very hard to keep things like toilets and sinks clean if you have hard water running through the pipes. Is it dirty? Not necessarily. Not dirty like we think of, like in a disgusting sense, like bacteria. It's minerals that's left behind by the hard water. Here is a sink in a hotel in Montana that had some of the hardest water in the country. And every time water would overflow in the sink, it goes out that exit drain, the overflow drain. And over the course of 50, 60, 70 years, whatever, however long they've been there, the minerals have piled up and you can actually see the residue. You can see it on shower heads. All of that gunk there is when the water turns off and the water stops flowing, it leaves a little bit of minerals behind. Anything that has water on it, typically, think about a faucet or a window in a shower. Well, there's always going to be a little bit of wetness left behind, right? And the water evaporates, the minerals stay on the surface because the minerals do not evaporate. So typically, if you have hard water, it's really hard to keep things clean because you end up with a little film of minerals all over everything where we have water. Really fancy wedding venue I went to one time, and they had groundwater that was particularly hard, and so their toilets had stains in it, and they had put up signs that says, "Hey, look, you know, please excuse the dark circles in the toilet. It's caused by minerals. We really do keep this place clean." It's something that is a problem if you have groundwater and it is hard water.
So this is a water bottle filling station at the Palm Springs, California airport, and this is an area that gets all of their drinking water from under the ground, which means there's a pretty good chance it has dissolved minerals in it, that hard water, and you can see evidence of it here. You can see this kind of scum here when the minerals were deposited on the surface once the water evaporated. You can really see it up there. Now, this doesn't hurt you, it's just minerals, it's hard water because they get their drinking water from under the ground.
Now, at least in all those situations I just showed you, you can actually see the minerals. But what about all the places in your house where you don't see the water? Consider something like a teapot. You pour water in there, and the water's in here. You put it on the stove, and you boil. It makes a whistling sound. You pour the water out, but nobody ever cleans the inside of a teapot because it's typically just water in there. If you have hard water, though, over time, you're going to wind up with a big collection of minerals left behind. Is it bad for you? No. Will it change the taste of your tea or your ramen noodles because there's a bunch of minerals in there? Possibly. You have a hot water heater in your house, which is a big tank that is full of water, and something is heating the water all the time, so there's hot water ready whenever you need it. Well, if you have hard water in that hot water heater, you're going to get a buildup of minerals, and you can see it here. It starts to fill up with minerals. It just gets caked. The heating element, that is what is touching the water to make it hot, gets covered in minerals. So hot water heaters, if you have hard water, do not tend to work as efficiently, and they don't last as long. Pipes are especially a bad problem because let's say I have a pipe this wide. That's how much water I want to bring to wherever I'm taking it. I need a pipe that wide. Well, over time, if you have hard water, it fills up the pipe, and now my pipe is basically only that wide. So I'm getting less water because the minerals have built up in the pipe. Washing your hair is a bit of a challenge in hard water as opposed to soft water. So you go to wash your hair and you rinse the water out of your hair. But remember, if you have hard water, what you wind up with is a bunch of stuff, a bunch of minerals left behind on your hair, which greatly affects the behavior of your hair. So people who have hard water, they actually have to buy a special type of shampoo that will help get all of the minerals out of their hair so that their hair behaves the way they want it to. Washing, cleaning, anything with a soap. We saw this in our lab activity. If you notice, the hard water only made about that much soap suds. The soap's not really sudsy. It's not cleaning very well. The soft water made a lot more suds. Soaps and detergents work so much better in soft water than in hard water. So if you have hard water, you've got some problems. So this is a big issue with laundry because the detergents that we put in our washing machine don't work as well in hard water as they do in soft water. So over time, your clothes can appear to be more stained. They're harder to get clean. The colors aren't as vibrant because you end up with a lot of mineral residue left behind. So here's how detergents work. If you wash with just water, you don't get things very clean because water really doesn't stick to dirt very well. This is why we use detergents, because detergents act as a bridge. A detergent molecule will stick to water and the other end of it will stick to dirt. So when we rinse water away, now water is stuck to the detergent, which is stuck to the dirt, and everything gets rinsed away. However, if you have hard water, the water is already stuck to minerals. And if it's stuck to minerals, it can't stick to the detergent, which means the detergent and the dirt get left behind a lot more often. So this is why if you were showering or bathing, even using soap on your hands, shampooing your hair in a place that had hard water, you might feel like it's difficult to rinse all of the soap out of your hair or off your hands because the water isn't grabbing the soap as easily because the water is already holding a lot of minerals and it can't grab the detergent. Now, anything in your house, like the dishwasher, the ice maker, they're all going to have hard water going through them. And you're going to get a residue of minerals left behind. Every time you turn it off, you're going to get more and more minerals piled up. Things that you take out of the dishwasher, glasses are going to be foggy. Silverware is going to have a little residue of minerals left on it. So how do we correct this? It's a problem. This is what a water softener does. A water softener is a device where water comes in it and then goes out. And in that water softener, you have basically a filter, and it's filled with a certain type of chemical that grabs the minerals and takes them out of the water before the water goes into your house. In places where hard water is an issue, it's a big business. Here's a company in Florida, Aquasoft. They want to soften your water. They want to take the minerals out of your water so your water behaves the way you want it to. My parents have a well in Florida. This is their well outside in their backyard. Florida has notoriously hard water. So they don't want hard water coming through the house. So after it goes in out of the well, it goes into this water softener, and it adds chemicals that grab the minerals and then just lets the softer water into the house. Here's an example of a hot water heater with a water softener and without. You notice a big difference between the amount of junk or the amount of minerals left behind. You can see it on the shower head. Big difference between a water softener and without. Where do you have hard water? Primarily, we're going to say in the Midwest, and Florida is notorious. If you've ever been to grandma's house in Florida, you notice the water seems to be a little different, has a different feel, different texture, certainly different taste. It's because the water there is hard. It has a lot of minerals in it because Florida's on top of limestone, and limestone puts a lot of minerals into the water. Great Bend, Kansas, any water fountain you look at it, you almost can't keep it clean. Now it's not dirty, it's just mineral residue. Same thing with a spigot there. You can see somebody turned off the spigot and the water stopped, but it left a little bit of residue behind. Some more examples. A fountain from a natural spring was Oklahoma in the Midwest, and a fountain in Florida. All that white stuff is minerals that are left behind because the water is so hard. People who live in areas where they get hard water sometimes choose to buy their water. They go to a water company that specializes in making the water soft enough to drink. Sometimes your home water softener doesn't give you a taste that you particularly care for. So a lot of people will actually pay to get water that has been purified and had all the minerals taken out because they have such hard water wherever they're at. Now, hard water problems in Atlanta, not a big deal. Two reasons. One, we don't get our water out of the ground. We get our water from rivers and lakes. Second, even if we used a well here, our rock is granite, and we saw that granite doesn't put a lot of minerals into the hard water. So why am I teaching you about this? If, hey, it's not a big deal for us here in Atlanta, why am I teaching you about hard water in a class in Metro Atlanta? Well, it's my point that you might not always live here. This is a good example. A buddy of mine who lived in Georgia for 52 years just recently moved to Ohio. And he moves into Ohio and he's got a well. And he's got a big, elaborate water softener, something he really didn't know a whole lot about. Here is his well, and the water goes through two sets of softeners before it goes into the house. That's my point for you, is that at some point in your life, you might move somewhere where this is an issue. Seepage, a whole new topic, but this refers to part 4 in the lab. This is the slow movement of groundwater, kind of like an oozing, not a flowing. Here's how it works. Imagine that we've got water kind of coming into the ground and it's able to get through the ground, and then it hits some clay. And we know that water doesn't like to go through clay. It kind of gets hung up in there. The clay will soak up the water, but it doesn't let it out very easily. Well, the water is going to try to take the path of least resistance. The water might actually flow out sideways. That's an example of what seepage is. Here's a real practical example. Here is a pond. This is at Centennial, and the pond is up here on the top of this hill. And that water in the pond is really trying to go into the ground like most stagnant water is doing. But we got a lot of clay in our soil. So in the process of going down into the ground via infiltration, the clay kind of holds the water up. And because it's on the side of a really steep hill, the water starts to kind of come out sideways. And this area on this hill was always wet because the water from the pond was seeping out sideways instead of going straight down into the ground. This becomes a really big issue for people who have basements and clay. So water comes down, lands in the clay, and it really has a hard time going through the clay. We know this. Your wall is concrete in your basement. We know the concrete is pretty porous. Water would have a much easier time going through the concrete than going through the clay, and that's the way it's going to move. And you wind up with something like this, which is bad news. We don't want water in our basements. This would be an even worse situation. This doesn't make a puddle on the floor of the basement. It's just kind of damp. Now imagine that this were a finished basement, like one that you would live in. You got drywall up and carpet. You would never even see this right here. But it is wet in the basement, which is going to help mold grow, which of course is very unhealthy. You take a product called a dry lock, and that's just one particular brand. This is a sealant. It's a waterproofer. It makes it so that the pores in concrete are all sealed up, and therefore water can't go through it. And this is what we did in the lab activity. This side here was covered up with dry lock. This side was just regular concrete. When you poured the water in it, you saw the water here went into the concrete right away. But the water over here stayed on the surface. It's kept itself out of the concrete, which is what we would want with our basement walls. Some extreme cases, sometimes houses have to be dug up around their basement because they keep on having water seep into the basement, and they have to put up this barrier that keeps water out entirely. It's an expensive proposition, but you have to do it because you don't want water in your basement. When they build new houses, next time you run out, you're seeing houses being built, here's a basement wall, and you'll notice this black paint. That's a sealant like the dry lock, and they paint the concrete with that before they fill this area up with clay. And so that when water gets in the ground, because it's going to rain, it won't seep through the clay and try to seep into the concrete basement wall. You also have a lot of fancy type drainage systems, something running along the house. So, hey, let's get water away from the house so it doesn't have a chance to seep in. I did a quick search, Atlanta companies that perform waterproofing work. This came up here. This is a quick search. This is big business here because it's a big problem for us here in Atlanta because it rains a lot and we have a lot of clay in our soil and everybody has a basement. A second thing you can do is angle your downspouts like this. And you'll notice most of the time your downspouts that take water, rainwater off of the roof are angled away from the house. And this is always a good practice. We don't want water right here. The more water that's up against the house, the more likely it is to seep into the basement. So you always have your downspouts aimed like this to put water away from the house. Here's a really extreme case, really steep hill back here, and the water was backing up against this house of one of my neighbors, and they were getting water that was just seeping into the basement all the time. So they built a fancy drain system, and they brought the water all the way out to the street. They kept water as far away from the house as possible. Permafrost and the frost line, these go hand in hand. All right, you know when it rains, the water's got to filter through the soil before it reaches the water table, which is this area down here where the ground is full of water. But if this process is happening someplace that's really, really cold, like Alaska, like it's cold so long in the year, the water in the soil freezes before it has a chance to get in the aquifer. And because it's so cold a large portion of the year, it might stay frozen year round. That's what permafrost is. Permafrost is water in the ground that stays frozen all year. In Alaska, they're having some concerns with changing climate. Temperatures getting warmer. The water in the ground is now not staying frozen year round. It's starting to melt some. Well, you built a house on top of ground that you thought would stay frozen, and now it's not. It's a little more liquid. So there's all kinds of problems in Alaska where roads are moving, houses are moving, because the ground underneath it is not permafrost anymore due to increasing temperatures on the planet. Now, this idea of a frost line, Kind of the same concept here. So water near the surface, even in Georgia, a little bit of water right up here near the surface. If it's cold enough or long enough, that water can freeze. But if you go deep enough down here, there's no water freezing down there. If you go deep enough, because the sunlight doesn't affect the ground that deep. The sunlight can only kind of affect the temperatures of the top part, the top soil. That depth to which water freezes is different where you are. So if it got really, really, really cold, maybe the water froze to there. If you were in North Dakota, Minnesota, maybe the water freezes to that depth because they have a longer winter and it gets colder. That's what the frost line is. The frost line is the depth to which the water in the soil will freeze. And it's usually expressed as a maximum value. What's the deepest that water can freeze? You can see up here in upper Minnesota, we're talking about 100 inches. Now that's 8 feet. So you got to go down 8 feet and you're still hitting frozen water. In Georgia, we practically don't have any frost line at all. It calls it 10 inches. That would be a very extreme case, and only up here in North Georgia, where it is colder. So our water in the ground really doesn't tend to freeze much at all. So once again, why am I teaching you this? Well, you might not always live in Georgia. So let's look at why this frost line is concerned. You know that when water freezes, it expands. If there's water under your house and it freezes and it expands, it's going to push on your house. Houses don't like to be pushed. Houses aren't very flexible. Here's an example of a house that, because of the freezing and thawing, it was being pushed and then not being pushed by water that was freezing. And the house broke apart because houses can't handle a lot of extra stress from pushing. More commonly, what you see first is something like this. You start to see cracks in the concrete where the house is being pushed by water that's freezing in the ground, and it's starting to crack the foundation. As a homeowner, if you live someplace cold and you start to see something like this, huge red flag that you need to have an engineer come out and look at the problem and fix it before your house winds up like the one in the previous picture. Same concept here. These posts are being pushed back and forth because of the freezing and thawing. Now that house is crooked. Decks are very susceptible for damage from frost heaving because they're a little bit flimsier structures and they're lightweight. They can get moved a lot easier than the rest of the house. All kinds of situations where people's decks fall off their houses because they were pushed apart when the water froze. That's the process of frost heaving, and that's the moving of an object. Usually we're going to talk about a house when the water freezes and expands, and we don't want to have that happen. So how do we fix it? Well, here's the same old deal again here. Let's keep water away from the house. The less water I have right here, the less water is going to freeze and the less it's going to push on my house. So always we try to keep water away from the foundations of our houses. Now, remember that frost line thing. Sometimes the frost line might be this deep. Maybe someplace else the frost line is this deep. You can build your house down below the frost line. You have to anchor it below that frost line depth, because then you have a portion, the anchor of the house is in ground that won't freeze and therefore won't get pushed and knock your house over. Up north, one of the most common ways to anchor the house is they build a basement. If you go to New York and places are really cold, they almost always have basements because the basement is going to stay warm. You're going to heat your basement at least a little bit, which means the ground right around the basement is going to stay a little bit warmer. Water's not going to freeze and therefore not pushing your house. Once again, most basements are about 8 feet deep. So unless your frost line is deeper than 8 feet, and that'd have to be a really, really cold location, most of the time a basement's going to help you keep your house from frost heaving.